Day 2 of Lesson 1 on Chapter 1 is continuing on functions. Yesterday we talked about the definition of a function being for every element in the domain. There is exactly one element in the range. And we're going to build off of that by evaluating some functions. So here is a function g of x equals x squared plus 8x minus 24. We just have to evaluate the function when you put 6 into that function. So when you put 6 into this function, then it's just a matter of calculating your output, which would give us 60 for an output. So if 6 is the input, 60 is the output. Pretty straightforward. You guys have been doing that for a while. Part B is a little bit more challenging because we're not just putting in a numeric value, we're putting in a variable expression. So we're going to have to put negative 4x into this function. Just a matter of using orders of operations properly. We'd get 16x squared minus 32x minus 24. And that would be your solution, not just a number like 60, but instead it's a variable expression. Shout out to Joe Hillenbrand, because without his help I could never do that problem. So thanks, Joe. All right, part C, we have to put a binomial variable expression into this function, which is going to be a little bit harder. So now I'm putting in 5c plus 4, and the error that a lot of people make is right here. A lot of people think you can distribute that exponent, but that's what I call an algebra 2 mistake. You cannot distribute that exponent. So instead you have to write out the 5c plus 4 twice, and you'll need to FOIL that. I'll also distribute. So now we get to the foiling part. And we'll do some simplification with that, as well as the rest of it here. We get 40c plus 8. Now if you combine all of your like terms, you get 25c squared plus 80c plus 24. So when the input is 5c plus 4, the output is 25c squared plus 80c plus 24. So that's just evaluating a function. Here's a famous mathematician named Leonhard Euler. His last name doesn't look like it'd be pronounced Euler, but it is. He's a Swiss mathematician, and he came up with a lot of things. Specifically, he came up with function notation, which we use all the time. He also invented the number e, which, if you remember from Algebra 2, is approximately equal to 2.718. We'll talk more about that number when we get to logarithms. So here are 2 rules that I'd like you to write down someplace for notes. This is rules that we're going to use as we talk about domains. Remember, domain is your collection of inputs. And so the 2 rules, the first one is to exclude values that result in a 0 in the denominator, because you can't divide by 0. And the other one is to exclude values that result in a negative value inside of a square root. And the reason for that is because you can't take the square root of a negative. So jot down those 2 rules someplace. Okay, we're going to use those 2 rules to do some domain problems, such as this. You're going to be given a function, and it's going to say to state the domain of each function. Well, again, we've got 2 rules that we need to pay attention to. The first rule is we can't have a 0 in the bottom of a fraction. We don't need to worry about that rule for this particular function because there is no fraction. But we do need to worry about getting a negative inside of the square root, rule number 2. So as an example, I cannot put a t-value of 0 into this function, because if we do that, we'll get the square root of negative 5. And you can't calculate that. There's many other values that you cannot put in, like I cannot put in t equals 1. because if you put in 1 for t, you get the square root of -4. So when you have a square root, what you want to do is take the expression that's inside the square root and make sure that it's greater than or equal to 0. So if we solve this inequality by adding 5 to both sides, it gives us t is greater than or equal to 5. We're going to answer, however, with interval notation. So I need a bracket on the 5. This is the solution we're looking for. Any number equal to 5 or greater than 5 we can put into this function, which would be the collection of inputs called the domain. Next one's a little bit harder. This one has no square roots in it, so we don't need to worry about rule 2, but it does have a fraction. So our main rule that we need to be concerned with is we cannot get a 0 in the denominator. So let's take the expression that's in the denominator. Let's set it equal to 0. And let's solve for x. Well, in doing so, we get two values, x equals 0 and x equals 7. If we put 0 into this function, that would give us 2 over 0. Oops, sorry. Let's try that again. If we put 0 into this function, we get 2 over 0, and that's not a value. So 0 is not in the domain. In the same way, if I put 7 into this function, that gives us 9 over 0, and you cannot calculate 9 over 0. So 7 is not in the domain. So there's one of two ways to write out your answer. So here's one way to write it, just as a sentence, all real numbers except for 0 and 7. Or you could write it as an interval. We'd have numbers less than 0 combined with numbers between 0 and 7 combined with numbers greater than 7. So this would be another way of writing that answer. So the bottom one in black is an interval notation. The top one is just as a sentence. Either way is fine. Last problem here, example 5 says state the domain of this function. Now this time we need to worry about both rules because not only do we have a fraction, but we also have a square root. And it's in the denominator. So like I said, anytime you have a square root, take the expression that's inside the square root, make sure that it's greater than or equal to 0. So if we solve this, we get x is greater than or equal to 3. But think about this now. The square root of 9 is both positive 3 and negative 3. So not only do we have to put nx values that are greater than or equal to 3, but also less than or equal to negative 3. As an example, if we put 4 into this function, that would give us 16 minus 9, which is 7, and so we get 1 over the square root of 7, which is a value. In the same way, if I put in a number smaller than negative 3, like negative 5, that would give us 25 minus 9, which is 16. The square root of 16 is 4, so I would get 1/4. So I can put numbers larger than or equal to 3, less than or equal to negative 3. Now let's deal with the can't have a 0 in the bottom of the fraction. If we put x equals 3 or x equals negative 3 into this function, that would produce a 0 in the denominator. So what I'm going to do is I'm just going to take, oops, let's fix that. There we go. This is what I tried doing. Take the equal to part off. And so this is going to be our solution. X value is greater than 3. X value is less than negative 3. However, I'm going to write this in interval notation. So numbers that are less than negative 3 combined with numbers that are greater than positive 3 would be your solution in interval notation. So that's how I would write the answer for this problem.